Evaluate the integral x to the sixth times the quantity x to the seventh minus 7 to the 42nd power dx. So in order to work this out, we're going to probably need the use of substitution. And in substitution, we pick some function u, which is going to replace a part of the original integrand. And the part that we choose needs to have two things happening for it. One, it's probably going to be an inner function of some other function. So this x to the seventh minus 7 is altogether raised to the 42nd power, so that is an inner function. But also, its derivative needs to look like some other part of the function. So x to the seventh minus 7 would be 7x to the sixth, which is really close to what's left over on the outside, which is x to the sixth dx. It's only off by a constant multiplier, so we can change that around and make this 1/7 du is equal to x dx. So this becomes the integral of, well, x to the seventh minus 7 is u, so we have u to the 42nd power, then x to the sixth times dx. Both of those together gets replaced with 1/7 du. Now, the integral here is just the power rule that's remaining. I have my 1/7 on the outside of the integral, and then I integrate u to the 42nd power, which would be u to the 43rd divided by 43, because I add 1 to the exponent and divide by the new exponent. I don't particularly know my 43rds, so let me grab the calculator to multiply that. So 7 times 43 is 301. So that's going to be 1 over 301. Since this is a definite integral, there's no end point. Sorry, this is an indefinite integral because there's no endpoints on my integral. I need to change back to the original variable. So u needs to go back to x to the seventh minus 7, and that's to the 43rd. And then we have our plus c.